Okay, so let's talk a little bit more about what molecules get across the membrane and when and how all of that happens. Getting across the membrane is called membrane transport, being taken from one side of a membrane to another. So here's an important principle that we need to talk about, is which molecules cross the plasma membrane on their own, meaning that they don't need a protein to help them across. If you remember, here's our plasma membrane, and some molecules need to go through these proteins, and others can just go right through the lipids. So let's talk about what's going on in this situation. Okay, so what we've got here, notice again, we've got a plasma membrane. Here's our phospholipid head that likes water. Here are the tails that hate water, they're hydrophobic. Okay, so this whole thing here, the plasma membrane on either side is water. And so I ask my students often, I put this picture up and I ask them to tell me what's going to make it across this. We've got a hydrophobic interior and water on either side. And you should come up with two things. One, they have to be at least a little bit hydrophobic to get across this hydrophobic layer. And then the other thing is they have to be somewhat small. If you have a huge thing come up here, it doesn't matter if it's really hydrophobic, it's going to have a hard time getting across that barrier anyway. Okay, so let's just take a minute and write those out. So get across the plasma membrane on its own, which means without protein help, if one, they are small, and two, either hydrophobic or mostly hydrophobic. These are the true rules. You have to have both of these, small and. Okay, if both of these aren't true, you can't get across. Okay, so what I'd like to do is I'd like to show you this picture, and I'd like for you to think about this for a minute and do this before I show you the answers. So it's small and hydrophobic, and you need to know these examples. These are examples that are up here for a reason because you will run into them often, so you must know these. Okay, so small and hydrophobic. Can it get across on its own, meaning without a protein to help it? Think about it. If it's small and slightly hydrophilic, which means it's at least partly hydrophobic, and ethanol, that's the alcohol that is in beer, wine, those sorts of things, so I'm sure as a health professional you'll be running into ethanol. Think about water. Think about large hydrophilic, small charged atoms such as potassium. Notice it's an ion, magnesium. You may need to go back to chapter 2 to remind yourself about whether these things are hydrophobic or hydrophilic, and then large charged particles. Okay, so go back, take a minute, work it out, and then start this again. See if your answers are correct. Alright, so this is what you should have seen. That small and hydrophobic get across on their own. So oxygen, carbon dioxide, important molecules, they get across on their own. Small but slightly hydrophilic, which means they're somewhat hydrophobic, such as ethanol, gets across on its own. Now water, this one's a little counterintuitive. It mostly does not get across, but we're going to find out that because it is so small, it's sneaky and a little bit can snake across. And it's actually important physiologically. And then you should have put for these other, they're either both of these are large, can't get across, and this one is small, but it has a charge, and ions are very hydrophilic and they cannot get across. So that means that these here do not need protein help, but these at the bottom, we still want to get glucose across. It gives our cells energy, but it's got to have a protein to help it. Okay. Now let's take a minute. You have this video embedded in your homework lesson. And so take a minute here and let's look at the two types of proteins that help us get things across. Okay, now you notice here's our phospholipids. Okay, here's our protein. And this one kind of looks like a donut almost, and the thing just goes through the hole. So it's like a little channel right through that membrane, and it's called a channel protein. Now this one, though, you may notice it changes shape, and it's almost like it carries it across. So it is called a carrier protein. Okay, so channel proteins and carrier proteins, and those are the two types right up here. Two types of proteins that can help molecules across that plasma membrane if they can't get through on their